So in today's lesson, we're going to be looking at what happens if you know the volume, but you're missing one of the dimensions. In other words, what if you know the volume, but you want to know what the height is, or you want to know what the radius is? How could I find that information? Well, since you know what the volume is, it should make you want to use your volume formula. And then a quick reminder that the volume formula of a cylinder is V equals uppercase B times H, where uppercase B is simply the area of the base. In this case, it's its circle. So we know that's pi r squared. So now that I know my volume formula, I'm going to look at my cylinder and ask myself, what information do I have? What information do I know? Well, I notice that I have the entire distance of the base from the center. And I remind myself from yesterday's lesson that the radius was only half that distance. So when you're given the entire distance, we call that the diameter, and we use the letter D for that. And once again, you're going to notice in the formula, I don't really care about this. I want to know what the radius is. So all I have to do is cut that distance in half. Well, 12 divided by 2, that's simply 6. So now I know the radius, I know the volume. I'm going to go and plug them into my formula. Instead of V, I'm now going to have 324 pi. Instead of R, I'm going to plug in a 6. So now I have this. I put some parentheses around the H. You don't need to, but it kind of helps me separate the two pieces of my equation. And now I'm going to go and take care of the exponent. So 6 squared, that's 6 times 6, which is 36. And also the feet gets squared, so I'm going to have feet squared. Now the right side here, I'm just going to go and rewrite it. These are both variables, so I'm going to squish them together with the 36 because this is just multiplication, so I can put everything nicely packed together instead of having the parentheses. This is an optional step. And now I'm going to ask myself, what did I really care about? Well, I want to know what the height is, so that means I need to isolate the h. I need to get the h by itself. I need to somehow get rid of the 36, I need to get rid of the pi, and I need to get rid of the feet squared. Well, since this is multiplication, I just do the inverse or the opposite, which will be dividing. So I'm going to divide both sides by 36 pi feet squared. The reason I'm going to do that is going to cancel everything out and leave me with just the h. On the left side, the pi's will cancel because, once again, anything divided by itself is 1. On the right side, the 36 will cancel, the pi's will cancel, and the units will cancel. So on the right side, what I'm left with is what I wanted. I have just h. And on the left side, I have some simple math problems. I do 324 divided by 36. That gives me 9. And then for the units, I remember my exponent properties. When you have the same base and you're dividing, you're supposed to subtract the exponents. And 3 take away 2 gives me a unit of 1. So I now know that h is 9 feet, or in other words, the height of the cylinder is 9 feet. Now let's look at an example where you're missing the radius. For this example, I'm not going to bother writing the units in the problem in my work. You actually don't need to do that. Just remember at the end that your answer had something to do with some units. It's going to be a lot less confusing when I don't have the units entangled with the work. Okay, so this time I have a cylinder and it's on its side. So if you don't like having your cylinder that way, you can just flip it and imagine it this way. Now you can imagine it standing straight up and down like a regular soup can or a soda can. And this time you're looking for the radius, and you know the volume is 637 pi. So same thing, I'm going to use my formula. I know my formula is pi r squared h. And I'm going to ask myself, what do I know? Well, I know that the height is 13 yards. I know that the volume is 637 pi. So I'm going to go and plug those in. And this is what my equation will now look like. And this time, I can't take care of the exponent yet because the r is a variable. But what I can do is put all this stuff together. So instead of having 13 parentheses, I'm just going to neatly write this and put the 13 in the front. So now I have 13 pi r squared. And then once again, I'm going to ask myself, what do I care about? I want to know what the radius is. So that means I need to get rid of the 13. I need to get rid of the pi. So in other words, I'm going to divide both sides by 13 pi because, once again, the opposite of multiplying is to divide. On the left side, the pi's will cancel, and on the right side, the 13 and the pi's will cancel. So what I'm left with on the right side is r squared. And the left side, I do 637 divided by 13. That gives me 49. And now I have to get rid of the square. Remember when we do Pythagorean theorem, to get rid of a square, we take the square root of both sides. And when you take the square root, the square root of 49 is 7 because 7 times 7 is 49. And the square root of r squared is r because r times r is r squared. So we now know that the radius, once again, since I didn't put my units, I'm going to mention them in the end. The radius of the cylinder is 7 yards. I hope these examples help. On today's worksheet, you're going to be doing these types of problems. You're going to be given a cylinder with a missing piece. In other words, you're going to be missing the height, or you're going to be missing the radius. and try to use these examples to follow along. Once again, don't bother with writing the units like I did with example 1. It's not needed. Just remember at the very end that you should have units in your answer. And that'll be it for now. Tomorrow we'll be looking at a new type of shape. We'll be looking at the cone. And then on Friday, we'll look at the sphere.